So, welcome to 2014 question A4. The drawing on the right shows a partially completed perspective projection of a tennis court. Right, what a lot of students didn't realize is in perspective, this tennis court is simply just a surface. It's just 2D. Okay, the net though included. Part A, the position of one vanishing point, VB2, is shown. Locate the other vanishing point. So look, the line's going this way. From S, you have to go parallel to them until it hits the picture plane, down perpendicular until it hits the horizon line. So these lines going up here, we're going to have to go parallel to them from S until it hits the picture plane. So we're going to go parallel to the lines from S until it hits the picture plane. Now, then from there we're going to go parallel to the perpendicular to the picture plane. So there's VP1. Now here's the end line of the tennis court right there. So I'm going to join that to VP1 and this one to VP1. Now if I was doing this actually in the test myself, I'd join S to all the points in plan in one go to speed things up. I'll do them one by one, right, for the purposes of the demonstration. Right, so the last line here, I'm going to get the end line in perspective. So I'm going to join that to S. Okay, where it hits the picture plane, down perpendicular to it. So there we go. I actually don't need to bother this one because I'm going to find it anyways when I join it to VP2. So I'm going to join that point to VP2 and put in your light lines, your construction lines. So I can heavy these here. Okay, now I'm going to get these two lines in perspective. So I need to join the endpoints to S. So then I'm going to go down perpendicular to the picture plane. So that's the start of it there. And this one here I'm going to bring down. And I'm going, because they're going that way, I'm going to join the VP2. Okay, now I'm going to get this line here. So I'm going to join the point, one of the points to S. I'll do this one just to make it easier for you to see. I'm going to join that to S, down perpendicular to the picture plane. Now it's going off that way to VP1. So VP1, the horizon line. So I'm going to join this to VP1. There we go. So there's the, there's a lot of the net done. Just to add in then, I have to add in the lines there because it is a net. Oh, my pencil's gone. So, mark in there. And there. Now, determine the true height of the net. Right, so any point on the picture plane is a true height. Okay, so I need to extend the net until it touches the picture plane. So I'm going to extend the net until it hits the picture plane. I'm going to go down perpendicular to the picture plane from there. So the true height lies along this line. Now, if I had the actual true height of the net, I'd step it onto this line, join it to VP2, join the end of the net to S, bring it down perpendicular till it intersected my two lines there. And that would be the net in perspective. So we're working backwards here. So from VP2, I'm going to extend my lines there through the net. And this is the true height here. And it'll be about 7 or 8 mil. So TH 7 millimeters. You want to write in the true height so you do want it just in case the doc marks. Now that question is essentially done now. If you want, you can stop the video. One particular student once asked me, can I not apply it here? That answer is only acceptable. Okay, so if you want to find the true height, okay, using this point here, what you would need to do is go perpendicular to the picture plane here on the line that touches the picture plane, the edge of the net, and then VP1 through that point, and that would also be the true height of the net. They'd be the same, so they would, because they're both points on the picture plane. As you can see. Right, cheers, thank you, bye bye.